Hi, Leo Drager here. I want to talk to you about chkdisk. In many cases, you'll come up with something like this. Do you want to scan and fix the blue USB drive F? There might be a problem. If so, would you like to basically scan it and fix it or continue without scanning? So what we're going to do is go to the command line. Okay. CD space dot dot, CD space dot dot, get back to the root, clear the screen, and do a chkdisk space / question mark. And what I'll do here is I'll try to make the font a little bit bigger just to make this a little bit easier for you guys to read. Okay, so chkdisk. All right, it's a relatively easy program to run. If you have a network administration background, you more than likely have used this, but you certainly can use it in the forensics process as well. So it's chkdisk, then the volume or the path, and then basically a couple of different options in what you can do. So F, okay, fixes errors on the disk. /V on FAT or FAT32 only, display the full path and name of every file on the disk. Sounds like a little bit lengthy of a process if you ask me. Or on NTFS, display the cleanup messages, if any. All right, so that's good. Very similar to like a verbose option. -R, locate bad sectors and recoverable readable information. Okay. Actually, that was this option here, -R. -L size, this only works for NTFS. Change the log file size so that the specified number of kilobytes. If the size is not applicable, display the current size. Okay, then you have a -X or /X, forces the volume to dismount first if necessary. Probably a good idea to do that, considering you shouldn't be analyzing something that's also has the potential of being used somewhere else. You have a /I, performs a less vigorous check of index entries. Now, I don't realistically ever do that. There probably is a reason which you can do that. However, whenever I try to fix a keyword there, fix a disk, I want the vigorous options because I want everything to get fixed. So I don't ever realistically use that in less vigorous. I would imagine, though, that it would be faster if you did check that option, but I'd rather have it fixed permanently than speed. So maybe that's just a little preference on my behalf. You have the /C. This skips the checks of the cycles within the folder structure. And /B, this reevaluates the bad clusters on the volume and also implies that you actually have a /R. So one of the things we're going to do here is if I open up, and we're going to do basically the F drive. This is the blue USB. Okay. So we're going to do chkdisk F : /fix. And then we could also do something like maybe a /B here, and maybe actually let's add a /F, /R, and /B, and then let's see if what comes out. So in this case, the Windows, the type of it actually is FAT32. So basically, none of the NTFS options are going to work. So that's a little foresight on my behalf. So let's just go back and do the -F. All right. So it's going to come up. The type of the file system is FAT32, and it's only a 400 and some odd megabyte drive. The name of it is Blue USB. The serial number is such and such. Now, this is helpful because in many cases, we need to get the serial number off of the removable device, especially if you're going to try to map a particular USB drive to only work with particular systems. So you can, in theory, use USB drives appropriately, although it's a lot of administrative overhead. So typically the easy way out there is just to turn off, USB drives, especially in some sort of government or federal space. Windows is verifying files and folders. The file and folder verifications are complete. Windows has checked the file systems and found no problems. However, I still have, let's see if it's actually still open. it looks like it went away because the little command prompt, would you like to fix this drive? It looks like that's gone now. Okay, so let's go back and try to do it again. Okay, so we had the F fix option here. That was for FAT32. We could also do an X here, and the rest of these are going to be NTFS options. So in this case, because it's actually FAT32, there's not much that we're going to be able to do here. But what we can do, and we can do this a couple different ways. Let's say that I want to, let's do it like this. So I'm going to go over to computer, manage it. I'm going to show you a different kind of view into this world here, so stick with me. So we're going to come in here to disk management. You can give it a second to open. It's loading disk configuration information down here, and you can see that towards the bottom. And there we go. So here's the FAT32. If we go to the properties of this, okay, here you can see the total size, the different tools. If you want to do error checking, so automatically -F or fix, and then scan and attempt recovery of bad sectors, you can do that as well right here. And that's easy enough to do, so we can just do that real quick. That shouldn't take long at all. So this is another way which you can fix a file. Oh, I'm sorry, not a file, but a drive or something like that. And your device was successfully scanned. No problems were found in the device. It is ready for use. If you remove the device or disk before all files were written to it, part or some of the files might still be missing. If so, go back to the source and recopy these files to the disk. And you can go basically get a high-level summary. So notice what's here. Okay, kind of looks familiar, doesn't it? Looks like exactly what we got here in this screen here. So if I just kind of reformat that a little bit, and then you can kind of compare these 505.147, 505.147, 505.122, 505.122. Looks the same to me. In other words, I'm happy with that. Okay. All right. So we can close out of that. So it scanned them just fine. And then there's really nothing else, just to be thorough here. There's nothing else in hardware. We don't necessarily want to share it. We're not going to add any password protection to it. We don't need a ready boost, and there's realistically nothing to customize. All right. So now what we can do is format the drive, and this will lose any data that is associated with it. So I do have a file on there that is a password file. But I'm officially changing from FAT32 to NTFS. Perform a quick format and enable and file and folder compression. That's not entirely relevant or accurate at this point. In other words, I don't have a specific need for that, so I'm going to leave that alone. And then also, if I wanted to change the file allocation unit size, I could do that. But being only a very, very small drive, that's irrelevant here. So formatting this volume will erase all data on it, back up any data that you want to keep before formatting it. Do you want to do it? Sure. So again, we have data on here. We got a password file on here, and I am in the process of formatting it, and we'll see if if it goes bye-bye. So now it looks like it's NTFS. Okay. So again, had data on it, just formatted it. Now I should have basically a drive with nothing else on it here. So I'm going to go down to blue USB, folders empty, whatever data was on there, bye-bye. Okay, nothing to see here. We can go to the properties. We can verify that it's now NTFS. And we're going to kind of do a couple more things here, and then I'll show you some tricks. Okay, so now we're going to go back to the F drive here. And now all of our NTFS options will work. Okay, so check this as verifying files, stage 1 of 15, 256 file records. Wow, that's a lot, considering I just formatted this. 256 file records processed. File verification completed. 0 large files, 0 bad files, 0 EA records processed, 0 reparse records processed. Check this is verifying indexes. No, this was stage 1, this was stage 2, 3, 4, and 5 all the way through. 0 unindexed files scanned and recovered. Chkdisk is verifying security descriptors 3 of 5. All right, so 256 security IDs processed. 9 data files processed. Interesting because it had nothing on it. 240 files processed in stage 4 of 5, and 111,000 free clusters processed. Okay, great. And then we get a nice summary here at the end. It found 21,568 kilobyte in 5 different files, 11 indexes, 0 bad sectors. So in theory, we shouldn't get a pop-up anymore that says, hey, would you like to scan this drive? So-and-so used by the system. So-and-so occupied the log file size and the available data on the drive. Okay, great. Nice. So had data on it, was FAT32, formatted it as NTFS, and now we can go back in and perhaps see if for example, we can't get some of the information off this drive in a later lab to basically see, if anything is left. And there's several tools you can do that to try to, do your hard drive recovery and things like that. So I'll leave it for there for this lab. That's chkdisk. I basically took a drive, formatted as FAT32, formatted as NTFS, got rid of all of the data on it. So this low-level format should be ready and handy, ready to go. Okay, so we're in a nice, good spot for if a user would have cleaned their tracks and then you find a drive with nothing on it, what do we do with it? All right, so good place to be in. My name's Leo Drager. Thanks for watching, and don't forget to check us out on Facebook, LinkedIn, YouTube, and Twitter.